Welcome back. Now we are going to discuss how we can create different types of plots using Seaborn library. When I say different types of plots, we have so many plots available like line plot, bar chart, pie diagram, scatter plot, histogram. There are so many charts that you can create. We have already seen how to create most of these using Matplotlib. Seaborn also provides you certain options to create all these plots. In this particular topic, we are going to discuss the same. Let's get to the topic. Relational plot. This is something I'm going to start with. Relational plots are useful for visualizing the statistical relationship between the data points. How two points are statistically related. Have you heard of correlation, causation? These are some of the popular terms in the statistic world. Like for example, during summer, the temperature goes up, the sales of the ice cream also goes up. So there is a statistical relationship between the two. The price remains the same, the sales goes up, the temperature goes up. There is a directly proportional relationship between the two. This is what we call it as a statistical relationship. How can I find such kind of interesting relationships? Using charts. When I want to find such relationships, what plot I need to use? That's where the relational plot comes into picture. So how do you create a relational plot? You have something called as rel plot, RELPLOT. That's the method that you are going to use to provide access, or it provides us the access to some other different access level functions which actually shows the relationship between two variables with semantic mappings of the data sets. So it is plotted using rel plot method. That's what we are going to use. The syntax is rel plot x, y, you define the axis, you define the labels, then data, which one are you going to pass it across, and then the arguments for that. This is how you create it. So let me show you how to run this rel plot. You will understand this better. I'm going to use the same high-res data set which we have initially uploaded. I'm not changing it, it's the same data set. And I'm using the same instance which I have created for Seaborn, that is SNS. And I'm using the same instance here, sns.relplot. And I'm passing parameters like the X label and the Y label, I'm defining it, that is sepal width and species. And then I'm passing the data which I have already imported. Now what happens? How does the rel plot look? Let's check this out. This is how the rel plot looks. So across different ones, versicolor is somehow like this, virginica is like this. Do you see any relationship between these data points? Not really. So the moment you start looking at the data in this format, it is easier for you to understand the statistical relationship between these data points. That's where the relational plot makes even more sense. Now same way, let's look at some other plots. Scatter plot. We discussed this already. Scatter plot is one of the very popular plots that we put across from the statistical point of view to understand the relationship between data points. Especially if I want to recognize the outliers that exist in the data set. Scatter plot is something which is very helpful. It is the mainstay of statistical visualization. It depicts the joint distribution of two variables using a cloud of points where each point represents an observation in the data set. All the points are plotted on a graph and you're able to see how the points are distributed. This depiction allows the visual, the eye, to infer a substantial amount of information about whether there is any meaningful relationship between them or not. Does this point belong to this particular distribution or not? If it is with the point, it is very well connected. If it is standing outside from the rest of the points, this is an outlier. These are the kind of inferences that you might derive by creating scatter plots. So how do you create a scatter plot in Seaborn? You use scatter plot method. So seaborn.scatterplot is the syntax, and then I pass on parameters. Almost the parameters are the same. How we created the rel plot, the scatter plot also does the same. So check this out. sns.scatterplot, x, y, and the data I'm passing it across. Let me execute and see how the scatter plot looks. Do you see this? Do you see everything equally distributed or everything very close to each other? Not really. It is pretty much scattered, isn't it? What is your inference of the data? When the data is so spread across, what is the meaningful insight that you're getting from the data? Think about it. Now, next one, line plot. For certain data sets, you may want to consider changes as a function of time in one variable or as a simply continuous variable. In this case, drawing a line plot is the best option. It is plotted using line plot method. The syntax remains the same, seaborn dot line plot. So SNS dot line plot, I'm giving the X label, Y label, and then I'm passing the data. Let me see how the line plot looks for the same data set that we have got. Check this out. This is how the line plot looks. Any inferences? Any meaningful insights that you can get? Different plots gives us different types of insights. It's all about you analyzing that and finding those meaningful inferences. Now we have understood the basic types of charts that you can plot using Seaborn. There is also something called as categorical plots. Categorical plots are used when we want to visualize the relationship between two numerical values. A more specialized approach can be used if one of the main variables is categorical, which means such variables takes on fixed and limited number of possible values. Like for example, gender, male, female. Then you talk about loan approval, approved or not approved. Credit card approval, approved or not approved. Credit card limit may not come here because it may carry any number of values. It can range from $1, it can go up to $10,000, $20,000, $30,000. It depends. So it is a continuous variable. It may not work there. But categorical variables where you have limited set of values, that's where categorical plots may make a difference. So there are different types of categorical plots. Bar plot, count plot, box plot, violin plot, strip plot, swarm plot, and factor plot. These are some of them because there are different ways of presenting this plot. Let's understand this because you may use one of these plots to understand the relationships between the data points, and this is usually part of the exploratory data analysis that you do. I told this while discussing about Matplotlib. The goal is to find meaningful relationships in the data points which is not visible to the human eye. By looking at the data from different point of views, you're able to understand data in a better way. That's exactly what you're trying to achieve with this. Now let's look at bar plot. A bar plot is basically used to aggregate the categorical data according to some methods, or by default, it is the mean. So it can also be understood as a visualization of the group by action. To use this plot, we choose a categorical column for the x-axis and a numerical column on the y-axis. And we see that it creates a plot taking a mean per categorical column. And how do you do that in Seaborn? You are creating bar plot method. That is something you use it across in Seaborn to create this plot. The parameters remain the same, x and y, and hue as the third one since we are talking about three-dimensional one. Order, hue order is something that you're going to pass it across. So this is very familiar now. SNS.barplot. You're going to use it across, pass the same set of parameters. Let me execute and show how the bar plot looks. This is how the bar plot looks of the three categories of the species that we have seen from the data set. Now, same way, can I create a count plot? First of all, what is a count plot? A count plot basically counts the categories that are there in the data and it just returns the occurrences of the count. It is one of the most simple plots provided by the Seaborn library, and all you have to do is use count plot method that is available in Seaborn library to trigger this. So count plot, give the data, it works. Let me draw that and show it across to you. Do you see here? Across each and every species, how many counts are available. That's what you're seeing. Across all the three, we see 50. That's the count plot. Box plot. Moving on to the next one. Box plot, a very popular one. It is also known as the box and the whisker plot usually. It shows the distribution of the qualitative and the quantitative data that represents the comparisons between variables. Box plot shows the quartiles of the data set, 25%, 50%, 75%, 100%. It shows the quartiles of the data set, while the whiskers extend to show the rest of the distribution. That is, the dots indicating the presence of outliers. Box plots, you generally put it across to check the distribution data, how the data is distributed. Syntax is very easy. You use box plot method directly. Let me show you for the same data set how we can draw the box plot. Again, my point would be very simple. Can you analyze and can you tell me what is the insight you are getting by drawing this box plot, what you are seeing on the screen? If you are able to understand that, you have picked up data analysis as a skill, because that's something you have to infer. Because drawing this plot, by this time you have understood, as a Python developer, it just needs one line of code to draw this plot. But it needs a bit of experience to understand what this plot is telling you. You need a functional understanding of the data and one line of code from the Python side to create that plot and infer from it. So I hope you are able to infer what box plot is telling you now. Let me move on to the last three sets of plots. I'll start with the violin plot. It is very similar to the box plot that we saw now, just that it provides a higher, more advanced visualization. It uses the kernel density estimation to give a better description about the data description. By the way, this is very simple. Violin plot is a method that we are going to use it across. Let me execute and show this across. Do you see a violin here on the graph? That's why it's called violin plot. How the data is distributed, very similar to the box plot, just that we are consciously calling it with an advanced visualization to see how the density is, how the data is distributed in each and every category. Strip plot. Strip plot is very similar to, it actually creates a scatter plot actually based on the category. You use the strip plot method to do that. When you draw the strip plot method, you will understand why this is called strip plot. Do you see this? It doesn't have a structure. So for every category, you are creating the scattering plot. How the data is scattered for every category. That's how you have created it. That's why it's called as a strip plot. Swarm plot, very, very similar to the strip plot, but the points are adjusted so that they do not overlap. And you create this with the help of swarm plot. Check this out. There is a clear non-overlap and there is a bit of more structure to the way the scatter plot is created. That's what makes this particular swarm plot different from the previous one. Last but not least, factor plot. This is the most general of all the plots. It provides a parameter called as kind to choose the kind of plot we want, thus saving us from providing the trouble of writing these plots separately. So the kind can take values like bar, violin, swarm, etc. You just use factor plot method to create this particular plot.